So what I'm going to talk about is the Kanban practice of managing flow, and give you some war stories and give you a kind of an understanding of my search for flow efficiency, kind of describe what flow efficiency is, and sort of tell you some of the challenges I've had with it. Before I start, I just want to give a shout out to Stuart, who's doing the visual notes. I think they're absolutely fantastic. Yes. He assures me the surfer is not a caricature, despite the nose on the surfer there. Yeah. So anyway. So my name is Chris McDermott. I am a coach, a developer, and a conference organizer. I work up in Scotland, and I organise Lean Agile Scotland, which is a 2-day event like this, which is running in September. A few speakers out there. The call for papers is still open, and it ends at end of May. Anyway, so last time I was down in London was back in November, and it was for the Lean Kanban UK conference. And its subtitle of Lean Kanban UK was Modern Management Methods. It's a title that the LKU have used for a number of the conferences. A big conference next month is called Modern Management Methods. So to start the conference off, David Anderson gave us 15 minutes where he talked about what that meant, why modern management methods, why modern, why now. And part of that kind of introduction, he talked about the Drucker challenge. So this here is Peter Drucker, who's the father of modern management. And David introduced us to his challenge that he set at the turn of the century. So the challenge was, that Peter Drucker set was, can we improve the productivity of knowledge workers by a factor of 50 times during the 21st century? What we've seen in manufacturing is a productivity improvement of a factor of 50 to 200 times in the 20th century. So Drucker is saying, can we do that with knowledge work? So if you think about manufacturing, a great example is the Model T. Ford, the Ford Motor Company, by the introduction of that process, they used the kind of scientific management, Taylor's scientific management. They dropped the cycle time, I'm carefully using that word, the cycle time of the production of a car from 750 minutes down to 93 minutes. They reduced the cost of a car from about $800 down to $300. So it was massive improvements, and that was right at the start when we were really getting into sort of mass manufacture of motor cars. So, but this is about knowledge work. He's asking us how can we improve knowledge work. So, and you know what knowledge workers are? We're familiar with the term, most of you. So, knowledge work is the idea of we think for a living. That's the work we do. We kind of do non-routine problem solving. It's primarily what we do in creative work, innovative work. We use convergent and divergent thinking to do the work. So that's Drucker's challenge. What David said was we could potentially get a 20% productivity improvement if we focus on something called flow efficiency. Then he put up a board that looked something like this, and identified these points here where we wait for work, and points where we're actually trying to do work, but we don't necessarily do it all the time in that process. So before I go any further with this, what's flow efficiency? What is flow efficiency? So I guess we all know what efficiency is, right? So efficiency is the idea of, in general, describes the extent to which time and effort or cost is well used for the intended task or purpose. As Russ Ackoff would say, it's about doing the thing right. But doing the thing right, for me, or efficiency, it depends on how you look at it. What lens are you looking at efficiency? So typically we look at resource efficiency. That's what we think about when we think about efficiency, normally in organizations. Resource efficiency is the idea we're utilizing resources as much as possible. And it's formed in 2 basic principles. One is we will break the work down into smaller parts as possible, and then we'll seek economies of scale. We'll try and get this work done repetitively by the same people in order to improve or to get the value from it. The quotes that I've taken here from the book called This is Lean, and to steal a phrase from Chris Young from LK UK, if you haven't read that, you're in for a real treat. It's a fantastic book. One more note before I move on. My mission at work is to ban the use of that word resource. We're not resources, we are people. So people efficiency. So that's people efficiency or resource efficiency. what we're going to talk about is flow efficiency. So what is flow efficiency? The main difference between resource efficiency and flow efficiency is resource efficiency is looking at the worker. Flow efficiency is looking at the efficiency of the work. So as it says there, we refer to this form of efficiency as flow efficiency because it focuses on the unit that flows through the organisation and not the worker that's doing that. I'll give you a little example of what that may be. Baz Vode and Craig Larman have this phrase, follow the baton, not the runner. For me, this was always rather confusing. I didn't really understand what it was until I got my head around flow efficiency. If you imagine the 4x100 metres is a highly flow efficient race. The idea is we want to get this baton 400 metres. What we're going to do is we're going to employ 4 of the fastest runners on the planet, and what they're going to do is they're going to run their 100-metre sprints and transition that baton on. We don't care. We're not caring for resource efficiency, because if you were to look at it from a resource efficient point of view, you've got 4 runners, and for 3/4 of the race, there's going to be 3 of them standing doing nothing. They're not adding any value. So how would we make a 4x100 resource efficient? So to make it resource efficient, what you'd have to do is you'd have all 4 runners starting the race together, all holding the baton and trying to do the 400 metres. That conjures up a bit of an odd picture. Then you have some lean consultant who'd come in and say, there's waste in this process, and he'd sack 3 of your runners, and then you end up with 1 runner. And then you'd never win the 4x100, despite the rule breaking that would go on. You'd never win the 4x100 because the fastest 400-metre runner, Michael Johnson, he did it in 43 seconds, and the fastest 4x100, I think, is the Jamaicans, and that's just under 37 seconds. So, follow the baton, not the runner. Let me give you another example. Anyone know who this is? English football fans in here? He might be going with you to Brazil this year. This is Fraser Foster. He's the Celtic goalkeeper. As a footballer, he would be highly flow efficient. What you want him to be is there to do the work when the work's required. If you think about Fraser playing for Celtic against Ross County, Inverness, St Mirren, he's not really going to do much. He's probably going to get about 4 minutes work a week, you know. But we need him there at that point to do the work. Ironically, the picture I've used, he was playing against Barcelona, which he was far busier that night. I think the Spanish media called him the Great Wall, La Gran Muralla. Maybe Jose could correct me if that's wrong. So, how would resource-efficient football look? Right. So we break the work down into bits. Yeah. So we've got all of the players. We'll put them all in positions. They'd all stand in their positions, and the value we'd get from this is touching the football. So what we need is 22 footballs on the pitch, and them to try and touch it as much as possible in the 90 minutes. That'd be a fabulous spectacle, wouldn't it? So bring it a little closer to home. I stuck this slide in this morning after Mike's talk. So do you know what this is?
Pairing station.
It's a pairing station. It's a pair chair. So pair programming, let's not look at pair programming in the whole, but let's look at it from the code review point of view. Is pair programming or afterwards review, is pair programming a flow efficient process or a resource efficient process? Flow efficient, yeah. So there is no, the work is flowing, there's somebody there to review as...
It's taking twice as many people, you're keeping twice as many people busy.
But it's flow efficient. They're there, they're ready to review when required, as opposed to queuing the work and then potentially generating, this is the superfluous work, the secondary needs of a process that isn't pair programming, a review process that isn't pair programming. You would have, it would go into some queue, you'd need some ticket management tool, you probably need one of these review source code tree review management tools, and somebody would pick it up, as Mike was mentioning earlier on, a senior programmer would pick it up in 2 weeks' time, and then it would come back into the process. And the senior programmer, as Mike was saying this morning, wanted to do that because it was efficient for them to do all of that work. They were seeking an economy of scale there. So, dig a little deeper on flow efficiency. What is flow efficiency then? It's value receiving time in relation to lead time. So if you think of this little simple value stream map, what we have at the top there is a point where value is received in the product that flows through this process. And at the bottom there we have waiting time. and that's against lead time. Now, to understand flow efficiency, we look at the value received time over the lead time times 100%. We've got a percentage calculation for flow efficiency. Let me give you a really noddy example. So if a value received for each of those points takes 5 seconds, our overall lead time is 100 seconds. We've got 4 points in which values received on that product as it flows through. You can all do the maths. 20% flow efficient, that process. Now, one of the things that David mentioned in his preamble LKUK was that flow efficiency as measured in our industry by a couple of guys, one who's actually next door at the moment speaking, Jolt, and a guy called Håkan Fors, is somewhere between 1 and 5%. That's how flow efficient we are doing the work we do. However, one of the key things to understand is when you think about that, what are the boundaries? Where do we start measuring this and where do we stop measuring it? This is a diagram that I know Andy over there has collaborated on, and Steve, if Steve's in the room. This is Steve's diagram. So I think this is quite nice. It helps us kind of break down some of this language we have, some of the confusion around some of the language we have. So we have, at the bottom there, we've got lead time. Lead time here in Steve's diagram is from when the customer places the order until the customer is fully paid for that order. Then we have service time. Service time is the time from the customer's order being placed to the work being made available to the customer. We can break down service time into a number of different times as well. We've got acceptance time. So customer places the order until the work item is acknowledged and put in the backlog. Queue time is between the work item being acknowledged and the work started. Then we have this kind of grey area of, is it flow time? Is it time in process? Is it process time? Is it system lead time? Certainly not cycle time when we actually do the work. And then we've got the delivery time. Now, where Håkan measures flow efficiency is in service time, and occasionally service time minus acceptance time or response time. So that's the point in which we're saying we're 1 to 2 or 1 to 5% flow efficient from the customer placing the order until we make it available to them. So that's what flow efficiency is. Now, this will be the shortest slide ever. Why? Well, it's a lean Kanban conference. I'm sure we're all aware of most of the whys we seek to make work flow. So faster time to market. There's no waiting in the process. A fully flow efficient process, there's no waiting. We ask to get it done, it's delivered. If we do that, we focus on that, then we reduce secondary needs, which reduces superfluous work. Back to my pair programming example, if we're to do a review process, we then need to manage the work that's in that process, whereas if we are flow efficient, we can respond very quickly to the work as it arises. And we don't need a lot of the kind of management of that work. Being flow efficient reduces our stress. We're not kind of battling with maybe multiple needs. We're not, we get a chance to kind of stay in control of that. We reduce context switching, we know about this. Smoother or less handovers if we're focusing on flow efficiency. What we'll drive to do is remove handovers from our process. And then faster resolution of defects. We all know that if a defect is found within minutes, it's much easier to fix. There's far less happened in that time. We all know, I've got a better understanding of what the problem is because we've just created it, as opposed to something that maybe takes weeks or months to get review on. It takes a lot longer. So if we're looking for flow efficiency, these are the whys. So how? So I really like this quote. I've heard the first part of it. I went searching for it last week on Twitter, and my friend Ian sort of pointed it out to me. It's, Kanban shines a light into the dark places of your org. Are you brave enough to keep it on? So the idea is Kanban's there to help us find the problems. Another good way of thinking about it is it's like an X-ray. It helps us see through to the bones of the problem. And then my favourite one is Kanban is like those red tablets the dentist used to give you in order to find the plaque. So you take the red tablets, you chew in the red tablets, you spit it out, and the plaque would be all highlighted. That is, Kanban doesn't provide the answers to our problems. Kanban doesn't remove the plaque. What it does is it asks the questions. It highlights where they are for us to then go and find them, or to go and solve them ourselves in our context. So what I want to do now is I'm going to take you through just half a dozen little examples of so stories that I've kind of encountered over my time using Kanban. So the first one's about bottlenecks. Is a quote from the goal, my early gold rat. Whenever the bottleneck produces in an hour, it's equivalent to what the plant produces. Every hour lost at the bottleneck is an hour lost in the entire system. So bottlenecks. So my first introduction to Kanban was around 2010. I was working in an organisation where, if anyone's familiar with the Marshall model, the right shifting curve, if you're not, I would say go have a look. It's a really good way of understanding the kind of the shape of your organisation, the way your organisation thinks. I'll give you a model for understanding that, sorry. The organisation I was working with was in the ad hoc space of this curve. So that's basically categorised by people come in the morning to do some work, they plan down what they're going to do for the day, and by 9:30, they've started firefighting. Their list gets thrown out the window, and they're just basically reacting to things. What I was trying to do in this organisation, this was a reverse logistics organisation that dealt with repair of electronic devices. What I was trying to do was install a software development team which was synergistic, a whole step away from the ad hoc space. So you're looking to use agile methods. What we found was that the organisation wouldn't let us run for a sprint without interrupting and changing their minds. Priorities were changing every other day. So suggested when look for a way to kind of develop a flow-based system. Stumbled across Kanban, and what we suggested was give us a promise that when we start something, you'll let us finish it, and you can change our backlog as much as you want. Just let us finish the one thing that we start. So we put a little Kanban system in place. Within a few weeks, the work was going out, customer was happy. When one of our managers found something that he wasn't really happy with, we developed a feature on the product that he didn't like. So he installed a policy that said, for every piece of work you do, I want to review it. So we put in a review column on our board. And before we knew it, we'd found a bottleneck, or we'd just created a bottleneck. So we had a kind of grown-up discussion about this. That wasn't going to work. Nothing was going to get out because he's never available. He wasn't able to do the reviewing work that he wanted to do. So I think we came up with a process where he would identify a couple of things at the start that he would say he would review, and the rest we would allow to flow through. My next example was where the team I was working with sought an economy of scale as opposed to economy of flow. So I joined the team, and we had this, I'm sure Agile folks have seen this before, the kind of oscillating sort of sprint delivery. So one sprint we would deliver nothing. And then the next sprint we would deliver twice as much as we thought we could. Then the next sprint we'd deliver nothing. And then after that, it'd be twice as much. The burn-up was like this one week, and then like that the next, and then like this. And it was so unpredictable. So what we asked the team to do was, what we talked about then was, let's try and unearth what the problem is. We'd have our stand-up meeting, and we all stood around somebody's monitor that showed the burn-down chart in Jira, but it just wasn't telling us anything at all. So we had asked the team if we could try and get a better understanding of the flow, how the work flowed through our team, and we came up with a board that looked like this. Then asked everybody in the team, let's just get a view for where the work is now. For all the stories we have, just jot them down in a post-it note, stick them up on the board. And it looked something like this. Our developers were looking for an economy of scale. They were saying, there's 10 stories that look the same. What I'm going to do is I'm going to start all of them, and I'll do all of the UI stuff, and then I'll do all of the middle tier stuff, and then I'll do all of the back-end stuff, and then I'll deliver it, and that's a way more efficient thing to do. In fact, they'd also do all of the testing bit at the end as well, all the unit testing. And that was a way more efficient thing to do. I was actually a developer on this team as well. Can you guess which one I was? So I was only doing one story at a time. It was a good whip limiter. So, a discussion about where we're losing the opportunity to get some feedback, where all this work would go to our test team, and it would all come back because of an assumption that was made right at the start in one of the UI components that was then replicated throughout the rest of the UI components was wrong. So discussions like this, looking at the way the work was then bouncing around and we weren't getting through it, led to us limiting WIP. We never actually explicitly limited WIP in this team. We just had a kind of mature discussion that said, let's not start everything. and we would talk about it every day, and we'd see the work, and then we got much better results. So Deming, yeah, it's not necessary to change. Survival is not mandatory. So this was a really interesting. This was quite a bit of last year we spent on this project. I joined a team back in January, I think it was, and the team, there was about 3 or 4 of us. By the time we came to have our second or third retrospective, there was about 10 of us. It really grew quickly. And at that point, the first alarm bell rang. The project leader, who was a lovely guy, put on we did a retrospective, and we'd stop, start, and puzzles, whatnot, and he put on the stop changing. Put on the board, stop changing. This is our second sprint with the team, and we're not. He wants to try and stop the progression of change and improvements within the process, and that's pretty much how it stayed for about 6 months or so. He emotionally resisted change. He really struggled with it. We would have the retrospectives. Well, we're too busy for them. We can't have them now. Any discussions I would have with him about change, he physically reacted. He would put his head in his hands. He would stare at the ceiling. And the minute the discussion I had made my point about the change we were looking to do, okay, time's up, move on. The change it wouldn't sit. There were so many other behaviours that would go on, which I can highlight to you as well. Anyway, this is the way the work worked in the team. We had our backlog of work, some analysis. We did a queue for 3 amigos, development, test, and so on. We managed to get ready to celebrate in there as well. When something reached test, and if there's any defects found on it, the tester would put one of these kind of pastel-y pink post-it notes on it and put comments on it to say what the problem was. Then what would happen is the developer who was last to work on that would go to fix the problem. So highlighted a defect there. What that meant was, the more luminous pink denotes blockers. This would block the story he was working on. Apparently we hadn't resourced the project for pair programming, so there was no kind of share of knowledge. There was no people working together on this code base. It was pretty much the work that came in was fed in. It was a push-pull system where the push ended about, well, in fact, the push ended about, the push ended after the dev had finished. Dev would say, I'm done this piece of work. He put it in ready for test, and as he stood up at the Kanban, he had a shadow behind him saying, pick that one. I want you to pick that one. He felt it was the most resource-efficient way the project leader felt it was the most resource-efficient way to do the work if the same person did the same stuff over and over again. What we found was, though, when that person wasn't available to do the work, it was blocked. It couldn't go anywhere. Another issue that we had with the push at the start of our process was there was no time for planning. He would just decide what the work was and he'd put it on the board. That meant when that story was blocked, or without completing that story, you couldn't complete any of those stories. The queue was completely jammed up because there was a dependency in there. That story had to be completed first before the rest were. And this is just how it went on. We just battled our way through this. There was a higher focus on resource efficiency in this than there was in flow efficiency. So as I was saying, the Deming quote, survival isn't mandatory. So next example, it's not enough to do your best, you must know what to do, then do your best, another Deming quote. So as team I was working with fairly recently, we would look at our board, and our board seemed okay. There was nothing really kind of radiating from that told us there was a problem in the flow. This was very early on with the team, so we didn't have a lot of data from using the board. What we found, the way we manage flow here was through our stand-up. We found a lot of the flow problems there. So we'd have, somebody would talk about, we'd walk the board from sort of left to right. Did I get it right? Yeah. We'd walk the board from left to right, and then people would talk about where they were with that, how they were getting on, what things they were finding. So this orange guy would say something, the red guy would say something, and the yellow guy would say something, and the red guy would say something, and the red guy would say something else, and so on until we got to the end of the board, and pretty much he talked his way through everything. And there's a couple of people standing there going, there's nothing for me to do. What we had was a liquidity problem. We've got one person who knows how to do the core piece of work in our team. We have many options of work, but we only had one person who could take that work and help or progress it. So what we did here was, this is an idea that Chris Matz talked about at Lean Agile Scotland last year. We created what he calls a liquidity matrix, a staff liquidity matrix. It's like a skills matrix. Chris was talking about it next door earlier. We got all the names of all of the people in the team. We put down on the left-hand side there all of the things we need to do to get work done. And then we asked the team to self-score. Go and say what scores you have against each of these different skills. So if 0, if you don't have a clue where to start with it, right through to 3, I own this. I know exactly what to do. I can take this work and get this work done. The very next sprint after that, once we put this up in place and everybody kind of got a really clear understanding of where our problems were. So, sorry, to go back a little second. The status there, if we've got a green in the status, that tells us we've got 3 people who are experts in this. And that means we've got 3 options to do the work, that kind of work. If it's red, we've got 1 or less experts. So what we want to do is try and make that status all green. We want to try and get as many people as possible who can do the work and choose to do the work. So the very next sprint planning session, the guy who knew the most, he basically volunteered to not do any work in the next sprint, and others would do it. So we highlighted 2 people who wanted to do it, who wanted to learn how to do it, and he supported them through the next sprint. And now we have 3 people who can do that work, and the work flows much better. Okay, another example. In God we trust, all others must bring data. So again, this team I was working with, everything seemed okay on the board. There was a couple of queues that we wanted to attack, but everything seemed okay. And then we started getting some lead time data. We started to understand how long work took to go through the team. We were sprinting the team, and it took 30 days. So we were doing 2-week sprints, and work was taking 30 days. It's never going to be able to deliver anything in these sprints. So we had a retrospective at the start of the year, and it was really emotional. People were getting really, really kind of, say het up, that's a very Scottish term, I'm sure. But they felt, very passionate about the work and what was going on, but nobody really knew where the problem was, why it was taking us so long. So, as I was saying earlier, let's gather some data on this. So, what I asked the team to do was, for every day a card was on the board, put a dot on it. On top of that, we want to work out where it was when the dot was applied. So we said, we'll put a number on top of all of the columns on the board, and you put a number in the dot that signifies where that card was at that particular day. On top of that, if you do nothing with that card on that day, give it a red dot. If you do something, you got a wee bit of progress on it, give it a yellow dot. And if you had a day where you spent all day working on it, give it a green dot. So this gave us a couple of things. This gave us fairly quick feedback to show where our work was idling. For the point of this card, we had, I think it's hard to see, but column 3 is where most of the work was idling, where it wasn't progressing. But it took us a little step further, and back to the start of the talk about flow efficiency. It helped me understand what the flow efficiency of this team was. We could then take 10, 15, 20 cards, aggregate all that data, and we could start to see the trends, where the work was queuing most. So if we look at column 1, 3, and 7, that's where the work is queuing most. Then we took this information into a retrospective, and we had a far more pragmatic discussion about the problem. The team were really excited after applying these dots for a few weeks. They're really excited to see the results, really excited to see where the trends of the problems were. So 7 is where test happens, and there's a lot of time work idles in there is because we find lots of defects. Defects are generated and they go back to the test, the dev team, who then work on the defects. When they work on the defects, they're not working on something else. That's why there's that big red column in the dev area. Number 3, because they're working on those defects. So the thing they'd pulled to start with was deprioritized for some defect that was coming through, which was stopping us getting something done at test. So that's fairly interesting. That's within the confines of that team. They can do something about that, and they have. Looking at column 1's entirely different. That's a more of an organizational problem. Let me show you. I'm going to go dig into that a little bit further. Before I do, here's another quote. There's Russ Aikoff. To manage a system effectively, you might focus on the interactions of the parts rather than the parts of the behavior taken separately. So this is I'm going to show you a little idea that Ian Carroll introduced. I first heard him talk about it in 2012 at the Kanban leadership retreat. This idea of systemic flow mapping. This is a way of drawing the flow of work across multiple teams in an organization or a department. So it's really simple. So a little board like this represents a team. This is a value stream. This is work flowing through from one end to the other. Straightforward, looks like a little Kanban. Clicker's not behaving. Then we can draw another team, and then we can draw the interactions. We can see the points in the flow where work transitions from one team into another team. And this board here is a cross-functional team on the left-hand side, and then a change management process in the middle. We then have work coming out of our change management process and going to a team that applies the change. So this is a team that deploy into managed test environments. On top of that, as you can see in the far left board, you can see 2 lines coming out. One furthest to the left of that board is the same idea. Work goes through a change management process, then gets deployed by a different team into production. So that shows you some of the interactions. Just to give you a wee bit of background, the boards on the right-hand side are for teams that are shared. So they're shared services. Multiple people ask for work from those teams with the kind of horizontal lines feeding in. So that, going back to the column number 1, I think, in the previous diagram, that doesn't show you this problem. What I've added is the red lines. The red line doesn't show the transition of work. It shows the transition of people. So people moving between different value streams to do different bits of work. So in the board I showed you a second ago, with the flow efficiency data, or the flow efficient charts, there was 3 people who worked on the first column of that board. Those 3 people were spread across 2 other teams. So the red we found in that was because the people were off doing work somewhere else. So what you can see is, with this picture, you can see where the queues are, and then sort of indications as to what may be causing those queues in the organization. You can see where the work is going and potential impact to this value stream by that work transitioning into different areas. So that's just a little bit of it. If you were to think, let's look at the rest of the department. So that's the rest of the department. So if you were to think about a constraint in this department, maybe that kind of point in the middle. So the idea here is to show management at a higher level, the whole system, how the whole system works, to then look at making slightly bigger changes. So we've got local changes the teams can make, but how do we then affect change at a slightly higher level? How do we give the managers a picture that lets them understand how work flows through the department? So there's a couple other things to add to this. So there's a portfolio. There's all the work that comes in to the department. So these green lines indicate work that flows into the department. And what you can see is a number of them have these little short green lines that say work that doesn't come from a portfolio but comes from somewhere else. So work that's generated by other places. So now you can identify where prioritization is going to happen. It's going to happen locally within these teams for the work. Also highlighted with these kind of little black-ended lines is where work not flows out of the team but flows out of the organization and goes to sort of other organizations to do the work. And then this is data I don't have, but you can just imagine what it would look like if we understood the flow efficiency across the whole department. Now this is just an indication. This is just something to give you a kind of high-level view. It's not a be-all and end-all of it. You want to, as the guys were saying earlier on, go understand these problems locally as well. So that's about it for me. Just one final thought on efficiency. There's nothing quite so useless as doing with great efficiency something that should not be done at all. As Russ Ackoff would say, and I always get this